Mhm. Mhm.
Jing, do you have the ability to mute other participants? My son, if anyone was curious. And everyone can see the presentation slide right there?
Yep.
Okay, we'll give it to 5:05 and then we'll kick off there, right? Right?
Sounds good.
Okay, perfect. We'll get going. Okay. Good evening, everyone. My name is Colin Pegues. I'm the chair of the Sudbury CIM. Join me from the Sudbury CIM is Neil Milner, who's the vice chair, and Yijing Sun is running the digital system for us. So if we have any hiccups, we'll be sure to message her. So yeah, welcome to the our annual panel discussion. Got an exciting one today, I think, for sort of a lesser known topic that is on everyone's minds right now. So Jing, if you just throw it into the next slide, please. Yeah, so this has been our season so far at a glance. We're now in February. It's kind of hoping that this would be possibly in person, but we're just sort of coming out of things. We are potentially going to run the March GMM, which is our Distinguished Lecturers Talk, in person, as things are starting to look more positive in Sudbury, as well as across the country. So that'll be a fine thing. We'll be back at Dynamic Earth if possible. So we'll keep everyone updated on how that's progressing. And then teams are already organized for our annual lobster dinner and dance this summer, as well as the golf tournament, which will likely go ahead because it did last year too. Next slide, please. Again, as always, a big thanks to all of the CIM team here in Sudbury who help put these events and all the rest of the events this season together, as well as organize how we manage fundraising and all the money we invest in local STEM organizations and school groups throughout the community of Sudbury and the various school board catchment areas around the city of Sudbury. So it's a big part of what these events are for, so that we can help fund the next generation of miners. Unfortunately, we should have been in the middle of MEMO right now in Sudbury, so that's the Maintenance, Engineering, Reliability, and Mine Operators Conference. But unfortunately, with the unknowns of COVID, it was decided to postpone this event until the fall. So we are back on track to host in September 18th to 21st. So again, I believe we'll be back out looking for speakers, and it'll be a hybrid event of in-person and digital. So again, with the title of Perseverance in a New World, which is sort of our reality right now, not knowing what's coming around the corner at all times. And so we're going to touch on that with that flair to mining and whatnot. So registration and abstract submission are available right now. And then, as mentioned, so we're very excited to have Jillian Holcroft on for next month in March. Fingers crossed for in person. Stay tuned. And so she is one of the CIM Distinguished Lecturers for the 21-22 period. And she'll be here talking to us about collaboration, innovation in mining and metallurgy. So looking forward to that. And again, stay tuned to our website and the various media sources to to determine how we're going to host this event in March. Good. So I'm going to touch on a couple of housekeeping items for the talk. So if you can, please mute yourself unless you're obviously one of the speaking participants. We will be taking questions. Please put your questions in the chat function. I will corral the questions and provide them to Ryan after the panel discussion is complete, so that we can pose them to the panelists. So if you could, if the questions directed at anyone or directed, please put that panelist name down, and then I will provide the questions to Ryan at the end in an easy format, so he's not trying to keep track of the chat group as we go. So questions in the chat function, and we'll get to those questions when the talk is done. So I guess without further ado, I'm going to introduce Ryan. So Ryan Bergen is our volunteered moderator for the event tonight, and Ryan works for CIM National as part of the CIM magazine, which is the flagship publication of the Canadian Institute of Mining and Metallurgy and Petroleum, and he's been with them since 2009. Has a background in humanities, training as a journalist, and prior immersing himself in all things mining. So he's experienced reporting in Canada and the United States, covering all kinds of topics. So small town Kansas to Kingston prison breaks and Montreal's famous crumbling infrastructure. It's my hometown. I'm very well versed in dodging chunks of concrete from the Metropolitan Highway and other various.
It's the season right now.
Oh, yeah. The potholes have opened up in Sudbury too. It's there's car eaters out there for sure. Yeah, and so he's been editor-in-chief of the magazine since 2012, and during this period, CM magazine has been recognized multiple times for editorial quality and its coverage of the mining industry. And pretty sure it's on the coffee table of most people on this chat too. So welcome, Ryan. Thanks again for your help, and I'll throw it off to you then.
All right. Well, thank you very much, Colin. It's a pleasure to be a part of this. Yeah, very much looking forward to coming out to Sudbury in September. And hopefully many of you will be able to make it to the May conference in Vancouver. We're pretty excited to be bringing everybody back together for that too. So those are my two plugs. So before let's get started with the speakers, and I'd like them to introduce themselves. Maybe we could first start with you, Adam.
Sure. Thanks, Ryan. So hi, everyone. Really want to first acknowledge Colin and the team from CIM Sudbury for inviting me to participate today. My name is Adam McMillan. I'm with Valley. I've been with Valley for about 20 years. Started my career in Sudbury and worked in mines and industrial engineering there, and then in our smelter complex. And for the better part of the last decade, I've worked in different planning and strategy roles, both in our Toronto office as well as Valley's headquarters in Rio de Janeiro. And so I'm really excited to talk a bit on this subject, and also to learn from the other panelists. Both Mark and Bob have a wealth of knowledge, and I'm looking forward to contributing to the discussion.
Great, thanks, Adam, and to you, Robert.
Thank you. Very happy to be here, and like Adam, I'd like to acknowledge everybody on the call today, and certainly hoping that I too can learn a thing or two about the topic today, which as we all know is pretty much the talk of the town with the EV revolution that's upon us. I'm Robert Morris. I'm the principal consultant for Morris Consulting. And the company primarily focuses on what we call technical metals, for lack of a better word, that are required to facilitate the energy transition. And specifically, I guess, if you drill it down, my main forte is on battery metals. So those metals that are required required for EV batteries, primarily nickel, cobalt, and lithium. I've been doing this for 3 years. Prior to that, I spent 13 years with Valley, working with Adam. For the last 5 years, I was with Valley. I was executive vice president of sales and marketing. for the base metals portfolio, which was nickel, cobalt, copper, precious metals, and PGMs.
Great. Thank you. And finally, Mark.
Good afternoon, everyone. And thank you for the invitation. It's going to be an interesting discussion this afternoon. I started my career about 30 years ago, working for a company that was then called Falconbridge. Spent about 20 years with Falconbridge, mainly in operations. I started with their mining projects group, and then worked into the processing group, and worked my way through the operating ranks, and I finished my career there as general manager of the Sudbury smelting business unit. Stayed a couple of years on with Xstrata after the buyout in 2006, and then started working for junior exploration companies, junior mining milling companies. I got this opportunity with Electra a couple of years ago, somewhat getting into my old stomping ground on Cobalt. The smelter in Sudbury, which I helped to manage, was one of the biggest recyclers of cobalt, and still remains a significant recycler of cobalt metal. And I'm glad that opportunity came up with Electra, and we'll share some of the main points in the industry and where we are today, and the exciting future that the metal has going forward.
All right. Thanks, Mark. So I think, Robert, we're going to give you the assignment of giving us kind of a Cobalt 101. Why are we talking about this commodity right now tonight? What is it, and how is the market changing for this metal?
Sure, I'd be happy to. So first of all, cobalt's been around for an awful long time, hundreds, if not 1,000 years. But it's not really until recently that it's been in the limelight. And I think there's a couple of reasons for that. First, compared with other industrial metals, the cobalt market is relatively small. To give you some flavor on that, the entire global cobalt market today is somewhere around 180,000 metric tons. Now, if you compare that to nickel, which is also a lesser known metal, the market there is about 1.8 million tons, so a factor of 10. And then if you compare it to copper, it's still copper's 10 times larger than nickel. It's I believe it's a moving target, but around 28 million tons annually is consumed. So that's really the first reason. There's not an abundance of trade in this metal, and it's therefore it seems to most of the people not into the day-to-day. It's relatively obscure. The other reason is more technical, is that cobalt is very rarely, if ever, used in its pure form, in its pure metallic form. So comparing it with something like copper, where you see, copper wire, copper rods, or aluminum panels, these kinds of things where you actually see the metal around your daily lives. Cobalt is primarily invisible, such that it's always subservient to another end product. What I mean by that is that some of the traditional applications for cobalt, one of them is super alloys, for example. So this is an alloy that is used primarily in high temperature situations, such as jet engine aircraft or landing gear for jet aircraft. And as an alloying agent, it's only part of that alloy. So you've got iron, you've got nickel, you've got other things. So it's not relatively visible. Another traditional application would be electroplating. where you see what would look like a shiny silver surface on something. You don't attribute that to cobalt, because cobalt is only part of that ingredient to make it whole. And the same you could say for chemicals. Cobalt is used as part of other cobalt or chemical compounds, such as what we see in batteries today, with what we've all known, well, a lot of us know now as the battery chemistry, such as nickel, cobalt, manganese oxide, for an example. So it always plays behind the curtain. What has driven the I guess the popularity of cobalt today is its predominant use in rechargeable batteries, whether it would be your mobile phone, your cell phone, whether it be Android or Apple, and more recently to the use in EV batteries. Looking at it in terms of context, in terms of application, batteries now represent over 50% of the world's consumption of cobalt. You see these other hard-facing applications, plating, the chemicals, each having a sliver of anywhere from 3 to 7% of the global pie. So the battery application itself has a life unto its own, and it is actually very, very critical for the successful rollout of this whole energy transition that we're talking about, particularly in electric mobility. Why is that? Well, the role that cobalt plays in the battery is actually very important. You have this battery chemistry, which nickel will give that battery chemistry its energy density, so it's ultimately its driving range and its power. But cobalt, in the form in the battery, provides the stability, and stability is hugely important. You've probably heard of Teslas and some other EVs, these news clips where they blow up or they catch fire. There is a lot of instability in a lithium-ion battery, and cobalt gives it that stability. And it gives it its longevity in terms of how many cycles you can actually have over a given lifetime of a battery. So those are the two primary reasons that cobalt has not been something that everybody has heard of, and today why you're seeing so much talk about cobalt itself.
So you mentioned that the share of cobalt dedicated to batteries has really exploded, and what does that meant for prices for the metal?
Yeah, over the past couple of years, we've seen the tremendous growth rate anywhere from, over the past 3 years for EVs, for example, from 56 to 126% year-over-year growth, and that's put pressure on supply on cobalt, as it has done with nickel and lithium, for example. They're all part of the same parcel of these energy metals that are required for batteries. So, what's happening today is that, we're seeing another price, I would say, aggressive price increase in cobalt. Today, it's trading close to $70,000 a metric ton. And to give you some flavor for that, a year ago, that was somewhere around, I think, $24,000 a ton. So it's doubled recently. We've seen this before, but we think that this is going to be more of a sustained, there's going to be more sustained pressure on the price. And it's not like supply is not growing. Supply is growing very quickly. The fact is, I've told other people this is a battle between classic battle between supply and demand, and who can grow faster. And we think that certainly over the next year or two, the market could be relatively balanced at current price levels of around $70,000 a ton. But we see kind of a cliff on the horizon that unless things change quite dramatically, we could be seeing deficits in cobalt supply by 2025 that could be quite significant and could have an impact to how we see batteries and EVs rolling out over the next decade.
So I want us to bring Mark in here to just get a little bit deeper into the battery side of things and the battery chemistries. I mean, I know that everyone speaks of the lithium ion battery where cobalt is, I don't know, how much cobalt is in your standard lithium ion battery, and where else is it in cars, or is it anywhere else in vehicles?
It varies depending on the battery that you have. I think you've heard Tesla say that they've gone from about 2 parts cobalt to 5 parts nickel, down to about 1 part cobalt to 8 parts nickel. And then there's still other manufacturers that are using a higher ratio of cobalt to nickel. But the thing to consider, and I just wanted to jump on what Robert was saying, is that there's 50 million cars manufactured a year in the world, and the way all the governments and the leadership is telling us direction here is that those 50 million cars are going to be 50 million electric vehicles in 30 years. And maybe by that time, it's not 50 million, it's 60 million, it's 70 million a year. If you just take that alone with the same ratios that you have today on cobalt in electric vehicles, that magnifies to 100, from about 120,000 tons a year of cobalt to about 750,000 tons a year of cobalt. So, and that's just in the electric vehicle business. What other chemistry is available to deal with such a attack on a scarcity on a resource like cobalt? There are, you've heard of the iron phosphorus battery that Tesla is working on, and they've had some success. I think the key is that a lot of the manufacturers may not be as efficient as Tesla is with their cars. In other words, the downstream aspect on how the car operates, and Tesla can go with a battery that has maybe a little bit less energy density and a cheaper battery. But the dynamics of the market are such that people want to get into the market. They want to build electric vehicles, and the nickel cobalt battery, which has been the predominance in the market so far, is the one that they've modeled a lot of their vehicles out of. So we don't see that changing substantially in the next 5 to 10 years. The vehicles needing the higher energy density, which brings in nickel cobalt, and the stability that Robert talked about, and the cycle. So we don't see that changing a lot. And even if success, Tesla continues its success with lowering the amount of cobalt, there's still a significant upside to the market, even if the amount reduces, the amount that's going to be consumed increases, because there's just more electric vehicles out there. In terms of other chemistry, yeah, there's other stuff out there that has had some success, but to gauge that success, you gotta put all the pieces of the puzzle together to really say we can't use cobalt. And that, you know, Tesla's probably ahead of the field in that, but not everybody else is. Not everybody, you know, is there as yet. And there's a lot of manufacturers that just don't do any R&D in that area, and they won't, because, you know, their strategy is different. So I think that as the industry continues to build itself here, you know, you're still going to see a significant role in cobalt, not only in the near future, but you know, looking 10 years down the line.
Okay, good. So bearing that in mind, let's go upstream a bit, Adam, and you know, let's talk a bit about where cobalt is coming from currently and where it may come from in the future.
Sure. Maybe just before I do that, I kind of want to just piggyback on a couple of comments that Mark and Bob made, and because I think, you know, cobalt's a really interesting metal. You know, Bob talked a lot about, you know, how it's, you know, 1/10 of nickel market size, and, you know, it's less than 1/100th the size of copper. Yet, you know, it's really, I think, emblematic of the challenges that the mining industry, the really resource industry, has in some of this energy transition that we're going on with EV vehicles. If you think about, you know, the rapid growth that we have in demand, you know, we're not, I've tried to find other parallels, and it's almost like, you know, if you think about the adoption of cars and petroleum, you have to compress that into 30 years, into 5 to 10 to see this rapid growth and change. And so it's a really unique challenge. So, you know, when you talk about battery chemistries and what those will be, these will evolve. We're seeing innovation and change, but the demand will still underline be there. Whether you go to an LFP, to a high nickel, cobalt, whatever type there is, you know, significant growth for all of these commodities. And I think that's one of the challenges. And cobalt really kind of illustrates, both from the demand side, but then also on the supply side, that challenge. So when we look at where cobalt has, you know, typically been mined, historically, it's typically a byproduct. You know, you'll find, you know, scattered cobalt, you know, as a primary source throughout. Today, you know, nowadays there's really only one primary cobalt mine in Morocco. The rest are byproducts. There have others that are going to start back up because demand is there. As Bob said, you know, you get such fluctuations in the price that it's hard to sustain that, you know, on the wild swings from, you know, say $20,000 a ton to 50, 60, 70,000. So, you know, much more volatility than we would find in some of the other commodities. And there is other volatility in nickel and copper, but not to that extent. And so typically today, you know, 70% of cobalt mined comes from from Africa, from the DRC and Zambia. You know, other sources where we'll find is, and those are from copper and cobalt type ore bodies. And so, you know, you're mining the copper and you've got the cobalt that's coming as a byproduct and able to sell that. Additionally, you know, we find it, say, in ore bodies similar to the Sudbury Basin. So you would find sort of those polymetallic where you're mining nickel and copper, you have cobalt as a byproduct. And, you know, and you can see it's a byproduct by the different recoveries that you can get through processes. Your hydrometallurgy are going to get significantly higher recoveries, whereas some of your pyro processes may, there's a site in Sudbury that can get really good recoveries, and there's another one that doesn't get quite as well. You know, and that's simply because it doesn't, you know, the value wasn't there. That changes through the cycle, and you look to improve that. You know, your third big one, and this is an interesting one that, you know, we've looked at over the years, is from nickel laterites and HPALs. You know, say VNC and other ones that are coming up in Indonesia. A significant amount of cobalt can be taken from there. And, you know, that's where we'll start to see some other growth. And then the last one is this, like I said, this primary cobalt source, say in Morocco, and there's some other ones in Idaho. I know there's an announcement just a couple of weeks ago from one in Missouri where they're looking at primary cobalt. And that's really driven from the demand and the long-term outlook. And that's from the mine side. I think also it's important to look at, you know, for the discussion today, in where does the process metal come from? Because, you know, there aren't a lot of processing assets dedicated to cobalt. And so a lot of cobalt is refined in China. And so When we look at broadly from an EV supply chain, there's, security that supply security that a lot of regions are looking to become better at. And so that provides opportunities for different companies, different ore bodies, and different resources to try and expand that. So, in Canada, there's, Mark's team is working to build a cobalt refinery in Canada. There's, Valley, we have two, one in Port Colborne, one in Newfoundland, and then there's Sherritt out west. Europe has one as well, but again, primarily it's in China. And the interesting thing is, outside of China, it's hard to find the metal that's suitable for batteries. So when we talk about nickel and cobalt, historically those are made to metals, and you can't just take pure nickel that we would find in, say, one of the refineries in Sudbury or in Europe and drop that into the battery. They want it in a nickel sulfate form. And so how do you transition that metal to that? How do you build refineries today or processing that can fit into that chemistry? So there's some opportunities there as well.
So one of the things I wanted to touch on here, just because I think there's a real tension, particularly with the electrification, is just like so much of the primary or so much of the supply comes from the DRC, and it just has a very bad reputation. At the same time, positioning the end products as virtuous living, getting away from the combustion engine. So there seems to be there's much more attention paid towards sourcing of cobalt, perhaps than some other metals, for better or for worse. And so I'm just curious how the industry is negotiating that and how it's responding to that kind of this trend kind. And so, and I guess I'll throw this one to Robert. And you're all more than welcome to have your say.
You're on mute.
Yeah, I got it.
There he
Thank
is.
you. After 2.5 years of doing this, you'd think I would remember to take my microphone off mute, but okay, there we are. Just coming back on Adam's comment about cobalt being a byproduct of nickel or copper. From a market perspective, this also creates some challenges, and primarily is because it's a byproduct. The elasticity of supply is a big challenge. And what that means is that really, if demand increases substantially for a byproduct such as cobalt, the supply response is not directly corresponding to cobalt. It's the cobalt is a function of copper and nickel assets. So it makes it harder for demand to respond in kind, which is a challenge, right? I think one of the areas where cobalt does have some elasticity of supply is, and maybe we'll talk about this when I comment next, is around the artisanal mining in the DRC. Again, 70% of the world's cobalt comes from the DRC. Artisanal mining can represent a large portion of that volume. When prices in effect get high enough, and let's say for purposes of arguments, when it gets close to $50,000 a ton, it incentivizes artisanal miners, which in many cases are family or tribal, with very unfortunately poor safety or other ESG controls. And as price goes up, the artisanal supply will also go up. And because of this artisanal mining, it really makes it difficult for the industry to really control the ethical standards around to which cobalt is being mined. When we look at that from a broader perspective, the whole concept of ESG is not, they're not simply buzzwords, as some people think that they are. OEMs, their brands are dependent on them ensuring that they are sourcing their battery metals in an appropriate way. Miners are under continual pressure, both from their boards, from their shareholders, and from the public at large, to extract these metals in a responsible way. So the whole value chain is immensely concerned, because it's kind of counterintuitive to say that you want to do this energy transition and you want to have a low carbon footprint and you want to make the world a better place, when you have so much, in this case, cobalt being mined in a fashion that's very, very difficult to control. It's difficult to control from the government, because the governments are not sophisticated to a point where some other Western countries are in their ability to enforce laws, for example. So it is a challenge. So what is being done about it? Well, up until today, I think it's primarily being governed by those players in the supply chain. So you look at a company called Umicore, who I used to work for. They're the world's largest consumer of cobalt, and they're one of the world's largest producers of cathode chemistries for EV batteries. So they have an entire internal protocol that they use to try to ensure that that the cobalt that they source is being done ethically. They're implementing both older governance approaches, but also utilizing technologies such as blockchain to be able to source right from the mine to the battery chemical. And then you have, in terms of cobalt, you have the industry association, which is called the Cobalt Institute, which have put together kind of a framework for its members to follow, to again ensure that this metal is being sourced as ethically as possible. Is it perfect? By no means, but you're pulled between two different directions. The EV battery market needs the DRC. If you don't have it, then the energy transition, as far as electrification, is in jeopardy. So there has to be a certain amount of pragmatism, in my view, around how we get from where we were 10 years ago to where we are today to where we should be in 2030, 2040. It's going to take some time. I think progress is being made. Can it be better? For sure. Is the industry committed to make it better? I would say on the whole, yes. There's always going to be players around the fringe. They're going to be taking advantage of unsavory ways of trying to profit off of this blue metal, which can make a lot of people rich. Absolutely. But I think the industry players along that value chain are the majority of them are absolutely committed to making this happen.
I'd like to.
Mark, you've unmuted yourself.
Yeah.
Go ahead.
Well, it's a really important topic. I'm going to tell a little story. I was in Africa probably about 15 or 16 years ago, and at the time, I was in management with Falconbridge, and we were sourcing secondary feeds. And there was an agent that we had met in Africa, and that agent wanted to sell us what was called white alloy, and it's basically a slag that contains cobalt. And when we asked for the chain of custody for this material, it kind of stopped at the border of Congo, and there was nothing beyond that. So we didn't end up dealing with that group, despite having high cobalt prices and having a whole bunch of other advantages to buy this material. And I think that's what good corporate citizens do. They just say we're not going to deal with this. We're not going to go there, and this isn't what we want to do. And I think Robert kind of touched on that. But at the same time, we've got to you got to respect the countries that you're working within and where the supply is coming from, and that will help to change behavior by not purchasing their product despite a strong demand for it. I think that's one lever we can pull. I think another lever is helping to champion through our governments, helping to champion change in working standards and health and safety practices. But as a corporate citizen, I think the biggest lever is that we're not going to deal with it if it's not done in a safe practice, in a ethical practice, and you kind of walk away from it.
Adam.
Yeah, no, I think I just wanted to, both Bob and Mark hit on some really interesting points that definitely apply to Cobalt, but also kind of just in general when we think about, resource industries. In that today, anybody buying materials wants that chain, right? It's not just Cobalt, it's your nickel. They're looking for it from that supply security. And where did it come from, right? What is the GHG footprint? What is that, is it ethically sourced? What are the labor standards? Things like that. So that's where change will come. But I think on the other side, that Bob hit on is that if you think about the DRC Congo, there's a lot of cobalt that's there, and so rather than just walking away from that, can we institute some change? Can we make life better for other folks in terms of how we do things? There will always be fringe elements. That's going to be anywhere. That's not country specific. That's everywhere in the world, and so we can actually try and make positive change by saying, look, these are the standards we want. We'll help that get achieved. And here are the systems and ways that we can do that right across the world. Not just in the DRC, but in all sorts of countries. Making sure that the products that we're buying have been sourced through a sustainable and responsible manner.
And then I guess the question becomes, how do you demonstrate that down the line? How can you verify that? How can you show someone that's the practice?
I think there's different technologies that are being evolved for that, whether it's in blockchain. That's one avenue that's been out there, and I don't know enough about that to be able to speak to that exactly. But there are also certifications. From a GHG standpoint, we've had some of our nickel rounds recently, certified by an independent agency. So there are ways, and I think that's going to have to occur because these large consumers of this, so the automakers, the OEMs, are looking for that certification. They want that, and so that's going to be part of the cost of doing business, is having these processes and systems in place to be able to show that through your supply chain that yes, I have adhered to, whether it's through labor standards, through anti-corruption, through GHG, whatever, that this is how I've done that from an environment, so that this product has that sort of seal, and that's going to become more and more prevalent.
Yeah, and I think on the bright side of this whole equation, what you do at the end of the day, you have the populace in general via shareholders in these corporations, whether they be OEMs, whether they be miners throughout the value chain, that are putting a tremendous amount of pressure on the industry to do this. And like I said before, just speaking in terms of the DRC, it's not going to happen overnight, but I think there is a will, and if there's that will, we will see dramatic changes over the course of the next decade, because when you have a global community that are consumers that are pushing for this, they're going to get what they want, right? Because it's those consumers that VW and Tesla and others are listening to when it comes to the course of electrification.
So I think we've all have consensus that there's real opportunities for Cobalt producers and for those in the business. And so what are the opportunities in Canada in this marketplace right now?
Maybe I can take that one. I can start.
Please do.
Okay. I think, you know, we're blessed with these natural resources here, then not only with cobalt, in situ cobalt in our ores, you know, we've got nickel obviously, and we've got lithium and lots of copper. You know, we've got all of the key battery materials to manufacture batteries, and for that matter, take things to the next level. I think, you know, what I've seen happen, especially in the last year and a half, is a significant flow of capital from government agencies to help start the businesses out. And you can see that some battery manufacturers and PCAM makers, and PCAM and CAM are the precursor plants. They're the chemist. They're kind of where the battery chemistry is formulated. These are processing plants that you know can be built here. You know, they will migrate to where the capital is being provided for them to help them establish the businesses. And I think you've seen the governments significantly you know start to get involved here, and they should, and they should, because it's something that Canada can do. I think I shared this with the panel the other day. I was at the Rivian plant in central Illinois just before Christmas. So this is a manufacturer that makes electric trucks and delivery vehicles, and I'm looking at how they assemble and how the battery modules are put together, and I'm there. This is stuff that, you know, we could do anywhere in Canada, and we've got all the base resources to initiate the entire process. So governments do have a role here, and the capital is going to flow where the governments are showing some support, and you know, certainly I think they're not asleep at the wheel in this. We have seen, and Electra has been on the receiving side of two loans, one from the Ontario government, another one from the Canadian government, and we're grateful for that. But there's a lot more to this equation that has to be developed yet, and Canada is as good a place as any. In fact, you know, being born and raised here, I think it's a better place than most. So we've got everything that the industry needs. I think with a little bit of steering from the government, we will attract the necessary investment to go full cycle. You know, and what I mean by that is, you know, fully integrated. Let's have the resources refined here, and let's have the manufacturing, you know, come out of those resources and make electric vehicles.
Yeah, if I can just make a quick comment to that, there's just really complimenting to what Mark was saying, that there's a massive movement on foot within the industry today. And what I mean by the industry in terms of EVs is that the movement to what we call co-locate and to localize the value chain, the battery value chain, and the EV value chain is something that really can be underestimated, because first of all, there's two main reasons for this. As was mentioned before, I think from Adam, or I'm not sure if it was Mark, that China today accounts for anywhere from 70 to 90% of the actual mineral refining processes for these various metals, whether it be lithium, or whether it be, I think cobalt, we're speaking about cobalt about 70% or maybe higher. And governments and localities in Europe and in North America realize that this is a security of supply issue. So having these capabilities within North America, or whether it be the EU, have become critically important. So security of supply is one thing. The other thing is cost. It's been proven, if you look at the raw material flow of cobalt or nickel or any other of these battery metals, if you look at cobalt can travel today 70,000 kilometers from where it's mined until it gets to where it's going to be put into a cathode material for batteries. This because it goes from the DRC, then it goes to China, then it can go to Europe, and then it can end up in North America. So in terms of cost, this localization and co-location of all of the components around the value chain are very, very attractive. And then thirdly, which a lot of people think is most important, is the carbon footprint of the current supply chain is far too large. How can you reduce that carbon footprint? Well, it's by being able to extract the metals close to home. It's being able to produce the PCAM and then the cathode materials, the battery and the car within an area where it makes sense. And Canada, unlike the US, for a number of reasons, partially because of mineralogy, partially because of government restrictions, Canada is one of the most natural places in the Americas that we can do all of this stuff. We've got the natural resources. We've got the ESG credentials. We've got the skilled workforce. So I see this whole localization of the supply chain benefiting Canada in ways that we couldn't have dreamed a while ago. I think that, like Mark said, the government needs to are doing things. I think they can do more, but okay, that's just my opinion. I would like to call out the government of Quebec, because I think they've been real leaders in this space in terms of understanding what the province can provide and understanding the needs of those in the value chain that are required to make this whole thing happen. I'm not saying certainly that the feds and the government of Ontario or BC are not doing what they need to be doing, but I think the government of Quebec has really stepped up here, and I just wanted to call them out on that.
Can you maybe elaborate on that? What are you referring to?
Well, what I can tell you is that I'm very much aware of a number of different moves within the supply chain to locate in the province of Quebec, and they didn't do that all by themselves. Sure, there's abundance of clean energy, clean power, hydropower, right? And there's infrastructure, all that other kind of stuff. But I think that what you will see over the course of the next, say, 12 to 18 months is you'll see cathode material producers such as, say, BASF in Germany will likely locate a big battery cathode materials plant in Quebec. I think the Valley has announced at their Investors Day that they've received some support for doing something in Quebec as well. So there's a lot of anecdotal evidence out there that that industry players are gravitating towards Quebec, not only for the abundance of natural resources and clean energy that they have, but as well as the result of a concentrated effort by the government agencies involved to attract this investment. So it's kind of like it's all the pieces of the puzzle had fit together, and the government has done their part to try to make this cohesive. And I think they're doing a great job.
Adam, your company was mentioned in that. Did you want to?
Yeah, I think I just, and I forget what was said actually on Valley Day, so I probably won't comment more other than to say, that, there's regionalization, and, whether we call it localization, regionalization, it's really, Canada has a really big opportunity to supply the North American market, right? If you look, Europe, Asia, China's really built out the supply chain there already. So that's one where, it's going to be a struggle. Europe is more advanced than we are here in terms of EV adoption and in terms of plants and things. And so I think, the opportunity for Canada is to really lean hard into the North American market. There's a huge client right just south of us. They don't have the nickel resources. They don't have the cobalt resources. They don't have the processing facilities today. Some of the, I think it was Bob mentioned, the environment here in Canada. Canada is a very friendly mining jurisdiction. We've seen that, through different surveys and that. So there are a lot of great opportunities. We have the talent, we have the skills. I think one of the issues we'll face is, how do we grow into that business and to that regionalization and set ourselves up? Because there is, when we talk about the auto industries are like, almost airlines where they're very nationalistic. And, we've seen that in some of the rhetoric in the US recently and other places. And so, if it's centered on that, how do we play into that? And so, it's not about having that entire supply chain, having the entire car built here and shipped over, but making sure that Canada continues to play a leading part in the North American auto supply chain, which we have over the last, 50 years. So as we transition to EV vehicles, we can play a greater part because we can actually be in the front end of that for a lot of the metals that get supplied into that, whether it's nickel, cobalt, lithium, copper. We have, as Mark said, we almost have an embarrassment of riches. And now how do we do that? And if you look at, say, cobalt or nickel, we've had a decade of, say, underinvestment over the last little while. And so how do you rapidly scale up? Because it's the growth, when we talk about supply deficits for cobalt in the latter part of this decade, they're huge. Based on forecasts, that's not sustainable. That's not going to happen. You're either going to have demand destruction or you're going to have some other alternative supply. And so what we want to do is to make sure that the metals are able to be provided for these industries such that you have that continued growth. And you have it from within. Canada plays a part in that, and I think we can definitely play a leadership in supplying. I would say kind of responsible metals that consumers can trust through that supply chain, whether it's cobalt or others.
Great, thanks, Adam. I don't know if Mark, there was something specific you had.
Well, I want to say that Robert hit the nail on the head. I mean, there's a lot of discussion around putting all of the pieces of the puzzle in one place. So having your cobalt plant, your cobalt sulfate plant, having the nickel sulfate plant, having the lithium sulfate plant, the manganese, so on, all in one place, for the very reason that it lowers, lowers your carbon footprint. The end product has a better ESG, and this is an industry that's kind of waving the flag, like the electric vehicle industry is waving the flag as like, follow us. We're the leaders when it comes to the environment. We're the leaders when it comes to low carbon, and ESG, and that combined with having all these facilities built in one place, the stars are aligned for that industry, right? It's another tap on the back that they get when they're doing that. So this is kind of the genesis of what's going on here. I mean, it's happening in other industries as well, but I think the electric vehicle industry probably, raises the flag first in wanting to be the greenest of them all, right?
So I guess looking a little bit further forward, and batteries at the end of their lives, and the metals and materials inside them. Robert, can you speak at all to how easily lithium and the other and cobalt and so on can be recovered from used end of life batteries?
Sure. Just reverting back to what Mark had said regarding the different chemistries, and whether they be nickel cobalt based chemistries or lithium iron phosphate chemistries. The advantage of the nickel cobalt manganese or nickel cobalt aluminum based chemistries are such that the economics and the recoveries around recycling those batteries are pretty compelling. They, in a sense, at current prices, but even at prices we've seen years ago, that the preponderance of these metals will be attractive towards recyclers to get these metals back into the supply chain. In terms of how easy it is, there certainly hasn't been a lack of announcements over the course of the past year about recycling companies that are established themselves all over the globe, whether it be Li-Cycle, a Canadian company, Redwood in the United States, Umicore is ramping up in Europe. There's certainly going to be no shortage of recycling capacity. There will also be government mandates of some sort that are going to ensure that these EV batteries are not going to end up in the landfill, particularly when you've got these metals that are such high value and important. So with that as a backdrop, this is really a timing thing. So recycling itself of these batteries, particularly for EVs, really aren't going to have any material impact probably for another 10 years. Why is that? Because when you produce an EV, you have an assumption that that EV will be on the road for 7 to 8 years. And there's also an assumption that there could be secondary uses for these batteries afterwards. Why is that? Well, because a battery should hold its capacity in a car, 80% of its capacity. When it gets below 80 or 70%, then it doesn't really become useful for a car. But for stationary storage in your home or for other applications, this is fine. This can make it last for another several years. So you've got a 10-year window, and we're just at the start of this EV revolution. So, if you just do the math, the factoring of this, it really shows you that it's not going to be a meaningful source of supply for another decade. Now, to the original question on ease of recycling, technology is getting better. It's been there. It's getting better. A lot of this is done by pyrometallurgy, but I think in order to really make this highly efficient and cleaner, it'll be done through hydromet processes. So the technology is there. It's getting better. Recovery rates are going to be high, and I think when it comes to these nickel cobalt batteries, this is part of the attractiveness, other than the energy density and other things, is that it does facilitate this life cycle through to recycling, where you have a lithium iron phosphate, where the economics around recovering these metals are not particularly attractive, just because of the low value of the metals that are in there.
So I know when we started preparing for this panel, I confess I had to look up Dr. Goodenow. and his rumored solid state batteries. Are all of the gentlemen assembled here familiar with Dr. Goodnow's rumored solid state batteries? And do they have, first of all, if you are, maybe you could introduce the audience to them, and two, what might that mean for Cobalt?
I'm gonna have to pass on that one. I've heard of it. I haven't really detailed the technology around that.
I was just going to say, if there's a voting function, can I put Bob on that?
You know what? I'm not even the real guy to speak to, but I mean, what the little I do know is that solid state batteries effectively what it says today. In a lithium-ion battery, you've got a liquid electrolyte. It's inefficient. It reduces the cycle life because these things called dendrites, they can form in the chemistry when the lithium ions go back and forth. And of course, it's dangerous. It's flammable. So if you, instead of using a liquid electrolyte, if you got a solid lithium metal, for example, on the anode, you could make this thing solid. Now, the impact around that is that it can increase energy density and cycle life to another degree, right? From 3G to 5G when we're talking about a mobile phone. So it's big. It doesn't eliminate nickel and cobalt per se, but it does reduce the amount that's going to be required to get the same level of energy density given a certain volume. So it doesn't eliminate the need for it, but it will reduce the overall requirements. And a lot of people have their own opinion, and I don't know how much mine's worth, but based on what I read and what I understand, we're still a ways away from this. There's a lot of talk about lithium air, zinc air, all of these chemistries that are going to upset the status quo. Well, I, for one, believe that this is going to just take a little bit more time than people think, probably through to the end of the decade before we have any meaningful commercialization. I mean, anything can be done on a lab scale bench, but when you're talking about commercialization, you're probably looking till at least the end of the decade before that's implemented. But who knows? Nobody knows. But there are still serious challenges with mass producing at a reasonable cost this technology. And lastly, this is on a backdrop against the massive economies of scale that are being put forward under the current status quo. That means these traditional lithium nickel, that a lot of things would have to be retooled and redone. So costs are continuing to go down in this area. So there's going to be a lot of catching up to do with something like a solid state battery that may or may not be first implemented on a Ferrari or whatever, where somebody can afford the extra $100,000. But I think we're a ways away.
Maybe just to complement what Bob's saying. I mean, when you look at, from that lab scale until you actually put it into your vehicle that you drive off the lot, there's a huge timeline in that, right? And so, it has to be, developed into such a way that it's safe, that it can be done economically, and all of those things. So, it's important to monitor these things and see where they go, but it's not something that's going to be on the car lot next year. I think if you're concerned about sort of, could something happen to demand for, nickel, cobalt, and other metals from an EV perspective, the technology is something we want to look at, but the timeline's longer. The bigger concern is what will happen if supply can't meet that demand, right? And then it becomes cost prohibitive to put in these batteries into mass-produced vehicles. And so that's something where we really need to be, I think it's a more pressing issue for us, is to say, how do we apply those projected supply deficits and make sure, because, to build a new car plant takes a couple of years, to build the technology in that. To get a new mine going, it's 10 plus. So if we're concerned about the latter part of this decade in terms of some of these supply challenges, how are we actually going to do that? And I think that's where, having government engagement, having different stakeholders, Indigenous right holders, different parts of the value supply chain there to help de-risk that, to meet that supply, is really critical if we're going to build that industry here within Canada.
Great. Thanks, Adam. So I think we'll move to questions shortly, but since we're on the sort of forward-looking statements, Mark, if you wanted your last piece on just looking out further ahead and what you see on the horizon.
Well, I mean, I think I started off by saying there's going to be less cobalt being used per battery, but there's going to be a net increase of cobalt required because there's just going to be more batteries out there. And I think, Robert talked a little bit about the recycling stream. I think that's going to be key for us to keep the ESG component down and in check. The technologies are out there. They're under patent. A lot of people are developing their own. We're developing our own at Electra. But it's going to be I think it's going to be a key component moving forward to help with the supply side of the electric vehicle battery. And at the same time, it not only looks at the cobalt component, the technologies that are being developed. They'll recycle the graphite, they'll recycle the lithium, they'll recycle the manganese and the nickel. So that's going to be a significant aid to meeting the supply side and keeping the ESG in check.
Great, thanks. So we do have a question here, and I know, Mark, you'd mentioned this earlier, how I believe Tesla has reduced the amount of cobalt that they put in each battery. And I'm curious, do you know what the primary driver for that was? Was that a technological? Was it just to improve the economics of the battery? Was it around politics?
I think there's a few things involved, and the stars kind of aligned for them on it. Number one, the iron phosphorus battery that they're now using in some of their vehicles, and they want to use more of. It's cheaper. There's no doubt about it. It's much cheaper. And they can, like I say, they've developed efficiencies in other parts of their vehicle that some of the other car manufacturers, electric vehicle manufacturers, haven't realized as yet, and hence they don't need the energy density and the stability that cobalt brings to the equation. Is that the future? Potentially. Is that going to be the future for every electric vehicle? Whether it's a truck or a car or a transport truck or an underground scoop tram. Is that going to work there? Maybe not. But it's going to probably take part of the market away for sure.
Great. So as we've been going along, I've been monitoring the chat and watching the questions come in, and I just remarked that a good portion have been focused on the ethics of procurement, and so I'm not sure who this question is directed. It's directed to the panel. I'm not sure who's best equipped to answer it, but how are, with the emphasis on ESG, how are downstream industries like bringing these this ESG imperative to bear in the investments that they're making and in securing and I guess being and showing that they are have an ethical supply chain.
It's one of the first things they talk about when we talk to them. As a supplier of cobalt sulfate to a battery manufacturer and then the end user, my experience, guys, is that in the last year and a half, they talk about that and they talk about recycling. And what are you doing on recycling? What's your carbon footprint? It's being pushed. It's being pushed, and rightly so.
Yeah, like I said before, I agree, and that this is just not lip service that they're paying here. The conversations I have just reflect exactly what Mark is saying. I mean, it's being driven by shareholders. It's being driven by the public, and these are who these companies are reporting to. And there's also a selfish aspect around it too, is that the brands of these massive OEMs are very, very valuable, right? And I don't know if you guys are as old as all of you are as old as I am, but Nike had a massive crisis about 20 years ago relating to the conditions of their manufacture of their shoes and other apparel. I think it was in China, and I think it knocked at one point it knocked a third of their market cap off. So there's also a little bit of selfish issue here that we're talking about. These guys are talking about electrification as a means to reduce carbon and to make the planet more sustainable. So you can't subvert that, and if you can, it doesn't last for long. If you look at VW with, and this is maybe counter to my argument because this only happened a few years ago with VW and the scandal they had around faking the emission levels coming out of their tailpipe. Well, you can look at that two ways. Well, these guys still aren't honest, but it did push VW to only second to Tesla in terms of this transition to electrification. So, I mean, if what they're saying and what they're asking their suppliers, they don't need to ask that unless really they were concerned about it. I think if you look at Cobalt as in isolation to this topic, it's harder than most, just because of the preponderance of supply that's coming out of the DRC. But I don't think we can say that the efforts are real, and they are. And I think probably Adam can even comment for Valley that this comes from board of directors. This comes from the CEO. Bonuses are structured such that these kinds of targets are met in terms of ESG. So I'm more of a skeptic than an optimist, but in this particular case, I got to tell you, I do think that the big players in this space are taking a leadership position in this.
Yeah, maybe just to add on to that. I mean, you're getting it from all sides. So you get it from your board of directors, you're from investors who say, look, we want to invest in a company that has, responsible, the full ESG. So we can talk about Cobalt, from a sourcing standpoint, but that includes GHG. It includes everything on that, anti-corruption, right? It's coming from clients, right? So, a couple of examples of that last year, we announced, a certification for GHG tracing on our rounds. When BHP and Tesla announced their deal last year, they talked about blockchain for sourcing on that, So customers are asking for it. Mark talked about that, Bob talked about that. And I think lastly, what's really important is employees want that. Employees want to work for a company where they know that it's, it's doing the right thing. And let's face it, mining hasn't always had that, There was a segment today on actually CNBC talking about nickel and cobalt. And I don't know if everybody knows that Bank of America has labeled these as opposed to FANG, the Facebook, Amazon. They've labeled these called myths. metals important for future technologies. And they talked about, how mining, oh, well, it's not that great. Nobody wants to mine. We need to do that. We need, we have a lot of work to do. A lot of the big miners have talked about that. We've talked about it in others, that, we want to engage with employees to show here is the value that we're generating both for local communities, national communities, and the global community. And so, it's really important to have that. And so you make these investments in terms of tracing. It's not going to come for free. You're going to have to make investments in technology. You're going to have to make investments in the audits on that, because you can't just say, well, I did something, I got some paperwork here. It's independent auditing that will have to come from that. And so, almost like ISO certification, those type of things to say, this is the supply chain that I've come from, and I've hit these standards, and it will be GHG, it will be anti-corruption, it will be, work standards, it will be the whole gamut of that, and particularly for the EV industry driving that, because people drive EVs because it's a philosophy of, I want to do something better for the world. I don't want to have a car that's polluting. And so what's the point in having that if your actually GHG footprint is bigger because of the metals that are consumed in it? And so right across the board. So I think, it's just going to continue to increase, and there's value in it too, right? If you can differentiate yourself as, look, I can certify that I am low GHG, that I have, the right controls and measures in place to trace where my metals come from, and they come from the conditions that you will be proud of, you will not be embarrassed from in the future. You can actually start to potentially in the future differentiate yourself from some of your competitors that way.
So you'd mentioned a partnership between BHP and
Tesla was announced last year. They mentioned about blockchain technology, so it was a public release on that. Yeah.
Okay. So I'm going to sort of riff on Patty's question here about, because I find that interesting. That's like, strikes me as so Patty's question is, how can companies promote that their cobalt supply is ethical? And one of the things that strikes me as quite effective is having that end product collaboration, like going from source to end product. I don't know, is that, do you see that as sort of like the developing trend of like, we are going to be sourcing all material from that particular company? Is that where we're going?
I think if you could, but I think, the scarcity of some of these metals, you want to try and get it to be able to trace it, right? To who's responsible and who can prove it. And again, I think that's going to be a differentiating factor. I mean, both Mark and I work very different kind of companies, but we're both looking to do this. So are a lot of great companies. That's what they want to do. And that will, the market is driving that, shareholders driving that, society and our employees. So it's putting in those right processes, and they're still developing, right? It's still very much a nascent sort of, process to do that, right? Hence that announcement on, can we use blockchain? Because blockchain is, and I'm sure there's folks on the chat here who can talk a lot more about it, but it's one way to do that, to show through your supply chain. And other industries do it. I mean, if you think about coffee, you buy coffee, you see the little label, fair trade, right? It's something that, you kind of have a customer preference for, right? Small purchase, but again, these small sort of changes can make big differences.
And so I guess, and I'm not sure if any of you can speak to this specifically. I myself haven't purchased an electric car, so I haven't seen, the material that was presented to me about that. But I don't know if that is part of the package when to the consumer, it's part of the pitch now, is the ethical status of the product itself. I don't know if that's become.
I just bought one, and I can tell you that there's a gap between what the OEMs talk about their suppliers to than the communication they have with their dealer networks. And I'm not speaking about Tesla here, because I think maybe Tesla is a completely different business model than the legacy car makers. But the dealer I bought my car from was an Audi. At the dealer level, they had no idea, right? The questions that I asked, they had no clue. They just said they were popular. And I think what they're able to do now is actually say, look, take this thing for a test drive, don't even, without even saying anything about, whether it's going to be greener or the impact that you're going to have, where the materials were sourced. it really is coming down to, and I think this is a big crossover moment between internal combustion engine cars and EVs. They're just better, right? They're faster, they're quieter, they handle better because of the low center of gravity. There's still range issues and some infrastructure things, but it's really, the pitch is just drive it, and then you can see. But if you start probing around anything other than that, and because for me, I'm in the industry, so I can ask questions, and I wasn't that impressed really with promoting those credentials at that level. So I think there's a gap between what corporate VW or GM is trying to bring to the public versus what's happening at the ground level at the dealers. I don't know if that answered the question, but I thought it was interesting nonetheless.
Yeah.
I think I just add too that I think our supply chain today isn't set up for them to be able to disclose that, right? You know, if you look at where a lot of the commodities are sourced from, they're still, particularly in the EV supply chain, come from China at some point, right? And you know, how do you? So they're trying to gear up to get ready for that, and you know, and that's where the opportunities get presented. But today, it's very difficult for them to report that. So you know, to your point, yeah, the dealers probably, they don't have a clue because they're trying to move the metal off the lot. So
Yeah, that's it.
It's a change, right? It's a change to how they're marketing their product, and some of the corporations can do it very quickly, and others not so quick.
So I don't know if we can do a lightning round, but we do have a few more. I know you touched on the volatility as just sort of the nature of cobalt and its vol. Is there anything that might smooth that out?
I think I'm gonna go back to recycling. I think that you know, the more you know, cobalt that's out there, the more opportunity there's going to be to recycle cobalt, and that'll help with pricing. I think Electra just put out where we think the market's going to be over the next few years, growing at about 11,000 tons of cobalt a year, which is significant in terms of the world market. But as I mentioned, you know, the more you have out there, and especially the more that is in the electric vehicles, the technologies that are out there to recycle that are gonna help balance the supply demand curve.
All right, I want to return to start with this one last thing that I know that Glencore has a very large footprint in the DRC, and so probably has a fair amount of influence in mining practices there. And I don't know if any of you at all can comment, I guess, on I don't know what sort of influence they're bringing to bear in the production of metals in DRC, or making sure that that metals that are produced there don't necessarily have the taint just because they've originated there.
I'll start. I think one of the best things going is that Glencore is a public company, and we just talked about, you know, other public companies that are being pressured from their boards, from their shareholders, from their investment bankers to do things properly with regard to ESG, and then you got intermediate buyers like ourselves that are feeling the same pressure from car manufacturers, and Glencore is feeling pressure from car manufacturers. So being a public company, there's a lot of scrutiny behind it, and I think that has helped to change things, and and Glencore no doubt has had to make changes over the last number of years, and will continue to do so. That they like others, because they're not the only ones in the DRC, will be asked the same questions and have to, service the same audits from their customers that the OEMs will have to do. So I think that has really helped with helping to manage the ESG issue.
Yeah, and I think you also got to separate the difference between what's happening on the artisanal side, where there is just the lack of the ability for any one entity or any one group to really to make a significant difference in a very short period of time. Glencore do not run artisanal mines, so they have copper cobalt mines that produce they just have a massive amount of their copper mines, but they have a massive amount of byproduct, just because of the DRC copper belt there. So they're running much more industrial type of an operation, even though I think it's well over 20,000 tons of cobalt per year. So I think that distinction really needs to be made. You just can't paint the Congo brush with one thing. Some other Chinese companies also have copper assets, and I think that they're starting to step up as well. But in addition to what Mark said, just around the pressure and the fact that they are a public company, if they were still a private trading company, maybe they wouldn't have the same incentive. I don't know, because there's a lot of good private trading companies out there as well. But I think they're doing what they can to manage the situation, in the community that they operate in. And it's not only the DRC. There's a lot of jurisdictions in the world where it's hard to operate in, right? To the same standard as Sudbury, for example.
Great. There we are. Hi, Colin.
Good. I mean, I can't thank you enough. That was enlightening for me. I feel like I know some stuff about some commodities, especially ones that come out of the mine I operate. But yeah, I got a lot to learn yet. So I do greatly appreciate the insight from all of you, and Ryan. You did an awesome job guiding us through that conversation. So really, I mean, again, on behalf of the Sudbury CIM, it's these events that really make our cause here in Sudbury possible. This engaging the community and getting everyone out and collaborating and understanding helps us drive what we do, which is getting the next generation into the industry, and gonna fuel this, or help support this demand, and making sure that we maybe grow that supply chain in Ontario, Quebec, and the rest of the country. So again, I appreciate you take time out of your personal schedules to help with this. Mark, I know you're calling from the airport, so a great big thank you to you doing this while you're driving. Adam, Ryan, you got kids running around in the background, I'm sure. So we're living that Dodge. And Bob, I hope we get you out to your golf game this afternoon. It's looking still sunny right there in Western Canada. So
yeah, it's a small sacrifice to make.
Yeah, something that really, I think I'll take home that really got to me. I think all three of you touched on it, was that timeline from ore body to something that's actually tangible that we're holding to be used, and how long that takes, and obviously the time it takes also for a new technology to reach the market. And yeah, we get so caught up in this sensational type news headlines that really drive conversation and stuff, and people don't really understand truly what it takes for develop technology or get a mine off the ground. So I really appreciate that context. Adds a lot of weight to the conversation. So yeah, again, on behalf of myself and the rest of the CIM team, and really appreciate the four of you taking your time out of our busy schedules. And yeah, I look forward to
To
the
you,
next one.
Colin, and to you,
Yeah.
and to
Thank
the
you.
many others behind the scenes that helped put this together. Yeah,
Yeah.
that was a
Nope.
real pleasure.
Thanks, everybody.
Yeah,
thank
so
you. Appreciate the
I got
opportunity.
two more plugs for the team on here. Ryan beat me to one of them. So we do CIM National Convention is coming up in May. Actually, Ryan, I got my thumbs up. The abstract I put in was accepted. So
Oh, thank goodness.
Yeah. And so yeah, looking forward to Vancouver and again as well to MIMO in September back in Sudbury. So that's a great event for the CIM in both those cities. So great. So again, yeah, lots of thank yous coming in from the audience there. And yeah, a really, again, heartfelt thank you from everybody here. Appreciate your time and commitment to this and to the industry and to knowledge. And let's just keep spreading the good word.
Very good.
Thank you.
Okay, thank you.
Awesome.
Bye.
Take care.